In this question, I want to provide the solution to exercise level 2, question 3 from the series and induction section of year 2 further maths core. So we're asked to prove by induction that n cubed plus 3n squared subtract 10n is a multiple of 3 for all n in the positive integers. And to make my life a bit easier, I'm going to let this expression equal u to the n. So I'm going to refer to u to the n being this expression here. And we want to start with our base case, because we were asked to prove this by induction. So the base case is going to be when n equals 1. So then u1 is equal to 1 plus 3 minus 10, which is equal to negative 6, which is negative 2 times 3. So it is clearly a multiple of 3. Now we would like to do our inductive step. So we are going to assume that this is true when n equals k, i.e. we are assuming that k cubed plus 3k squared minus 10k is a multiple of 3, so this is uk, and it might be helpful for you to say that this is equal to 3m for some integer m. And what do we want to show? Well, we want to show that it's true when n equals k plus 1, i.e. we want to show that uk plus 1, which is equal to k plus 1 cubed plus 3 lots of k plus 1 squared, subtract 10 lots of k plus 1, is a multiple of 3. Okay, so let's start with uk plus 1. And let's just expand out these brackets. So k plus 1 cubed is k cubed plus 3k squared plus 3k plus 1 plus 3 lots of k plus 1 squared is k squared plus 2k plus 1 minus 10k minus 10. And if we just collect our like terms now, we get k cubed, 3k squared plus another 3k squared. From here, we get plus 6k squared, and then we have 3k plus 3 times 2k, which is 6k. So we have 9k subtract 10k, which is negative k. And then finally we have 1 plus 3, which is 4, subtract 10, which is negative 6. And now we want to use our inductive hypothesis. So now we want to take what it is that we have assumed, so this assumption here, and make a substitution into this. Well, there's lots of different ways we can do this, but I'm going to make k cubed the subject. So if we have k cubed, we can see that this is equal to uk, subtract 3k squared, add 10k. I'm going to make this substitution into here. Well, what does this then become? This becomes uk minus 3k squared plus 10k plus 6k squared minus k minus 6. And simplifying and collecting like terms, this is uk plus 3k squared plus 9k minus 6. And this term here is divisible by 3 by our assumption, because we assumed that it was a multiple of 3. And these remaining terms here, there is clearly a factor of 3 there. So we can see that the whole expression is definitely divisible by 3. And if that is not convincing enough for you, we can let uk equal 3m. So we get that this is equal to 3m plus 6k squared plus 9k minus 6, and take a factor of 3, And we can see that this definitely is a multiple of 3. So what have we shown? Well, we have shown that if n equals 1, un is divisible by 3. And if un is divisible by 3 for n equals k, it is also, un is also divisible by 3 for n equals k plus 1, and so un is divisible by 3 for all integer n greater or equal to 1. It's worth pointing out that we don't need to do this proof by induction, and we can actually prove this statement a different way. But in this particular question, we were asked to prove by induction. However, I think it's worth having a look at a slightly different way of proving this. So if we take the expression n cubed plus 3n squared minus 10n, we can factorise that firstly by taking a factor of n, and then by factorising that quadratic expression, we get n plus 5, n minus 2. Remember here that n is an integer. So we want to show this is divisible by 3. Well, there are 3 cases to consider. Either n is a multiple of 3, or it is 1 more than a multiple of 3, or it is 2 more than a multiple of 3. Because if it's 3 more than a multiple of 3, it's a multiple of 3. And all integers are either multiples of 3, 1 more than a multiple of 3, or 2 more than a multiple of 3. We might want to give some algebraic expressions for this. Either we have n is equal to 3m, or n is equal to 3m plus 1, or n is equal to 3m plus 2. And there are only for some integer m, and there are only possibilities. Well, if n equals 3m, we definitely have a factor of n here. So this is definitely divisible by 3 because n itself is a multiple of 3. Well, if n equals 3m plus 1, then n plus 5 is equal to 3m plus 6, which is a multiple of 3 because this is 3m plus 2. So therefore, n plus 5 is a multiple of 3, and so n plus 5, n minus 2 is a multiple of 3. And so our expression is a multiple of 3. And finally, if n equals 3m plus 2, then n minus 2 is equal to 3m. So n minus 2 is a multiple of 3. And again, so n plus 5, n minus 2 is also a multiple of 3. So we can show that in each of the 3 possibilities, either n is a multiple of 3, n is 1 more than a multiple of 3, or n is 2 more than a multiple of 3, one of those factors of our expression un ends up being a multiple of 3. And we didn't have to use induction there.